I hate accuracy and precision.
You do?
Yes.
Yeah, it's the easiest thing
I
ever
could
anyway.
never get my mind wrapped around it as a dumb freshman.
You'll get your mind wrapped around
I'm
it.
such a scrub.
Alright. In a nutshell, here's really the difference between accuracy and precision. Okay? You're accurate if all of your answers are what?
Close to each other.
No.
All correct.
Are close to the actual answer.
Like this shot
Nope. No.
is very accurate.
It was kind of. It was close. Precision is how close your measurements are to what?
Each other.
Each other. Okay? So you probably have seen this. I mean, I think this is a pretty adequate job of explaining accuracy and precision. If I have a bunch of arrows that I shoot, they all land right there. Do you think it's, don't yell it out loud, raise your hand. Accurate, precise, both, neither. For those of you who,
Don't raise your hand out
Good,
loud.
I'm sorry.
it's just saying it's just precise?
Yes.
Why?
Because, well, I mean, you don't have, if you don't have the, if it's not where the target, where you're supposed to hit,
Yep.
then it's not accurate, but they're all together, so it's precise.
Yeah, they were very precise in being able to hit one small little area, but they were not close enough to the target for us to say that's pretty accurate. Okay? How about this? Tyler? It'd be both. Okay? Now here's my question. Can you be accurate without being precise?
Yes.
Yeah, what if
This
you
is where I debate. This is where I debate.
What if you only have
Here's why.
one point that's accurate?
Here's why.
Not multiple.
Here's how the book I think describes it. The book describes it is if your average is close to the actual, then it's accurate. But here's my problem with that.
Oh,
That would
If I took an average of that, where would that land?
in the middle.
Right in the middle. So am I really accurate?
No.
No. Do you see what I'm saying here? I think I'm going to debate what the book says, and the book says if you,
I think it's the average closeness of the target.
that might be true.
Yeah.
That might be
makes
true.
sense.
But how do you, I mean,
Like how far away they are.
that could be true.
See, if you had like 2 points that were like on the bullseye and then a couple others that were just kind of out
They
there,
would average out.
I would say that.
Yes, I would agree. Like if you had something like this, and they had like one out here, I would say you had like one really, you know, maybe you sneezed while you were shooting or something.
What if you only have 1 point? Can you be precise with only 1
No,
point?
you cannot be precise if you only have 1 point. In fact, I don't know if you can say even with 2. You probably need at least 3
But
to.
you could say accurate.
Yes.
Depends on what you're targeting. The whole thing is.
Alright guys, don't make this more subjective than it needs to be. Okay, we're hurting Brevin here.
Target.
Okay?
General.
How about
Oh,
this?
look, it's on the page.
That is.
I'd say
That's kind of.
One of them is accurate.
Okay, well, I would say as a whole though, these are neither. They're not precise because they're not close together. And they're not really that accurate because there's only one even remotely close to the center. Okay? I feel like, you feel pretty good just thinking about this from a bullseye example. Now, would it make sense with numbers? And we'll pull up some number examples here in a little bit. But I think that's fairly sufficient, I guess, for identifying that. Whoever's doing that stuff. All right, percent error. Part of how we can figure out how accurate or precise we are would be how far off or how much error we have. Here's your equation. You're going to want to write it down. There we go. 3.
Uh-oh.
You guys don't have your notes out?
There it is.
I have it.
I was on the wrong page.
And this should be absolute value here.
So if it's negative, it's positive.
Yes, that's how that works. Absolutely.
You're so funny.
Who is me?
Me
All right.
over
Observed versus accepted. What do you think I mean by that?
there. I
What it-
observed is what you got.
Yeah, like if you shot your bow and arrow and you observed where it landed, and the accepted would be where it was supposed to land. So essentially this top part is the difference between what you got and what you should have got, or what you wanted to get. Okay, that would be your difference, and then you would divide that by what you should have got for a how far off are you actually? What's your error? Right? We'll just do this one quickly together. I'm not going to do both of these since I don't need to do two on this. It's pretty self-explanatory. You measure the mass of a product. Here's the thing. You measure. So what's this number going to be?
Your measurement.
You're
Observed or accepted?
Observe.
Observed. You did it. Okay? According to your theoretical calculations, in theory, aka accepted, if you want to put like theoretical next to that if you want, I'm fine with that. Okay? You should have gotten 3.92. So, your observed is 3.8 minus your accepted divided by 3.8. No, 3.92. Sorry.
96 weight, right?
Times 100. So it's not going to be negative 0.12. You can't have a negative percent. Does that make sense? So it's just 0.12 divided by 3.92. Anybody got it? Times 100? 3.1% approximately. I would say that's pretty accurate. If you're only 3% off, now it depends on what you're measuring. If you're measuring with a really, really precise instrument and you're 3% off, that's a problem. But if you're not using a really precise instrument and you're eyeballing it or something, you're 3% off,
manual.
not a big deal. Okay? Questions on this? Is this difficult? You want me spending more time on this? You with me, Rachel? Okay. Alright, I'm not going to do the next one then.
I got a negative.
What?
Well, then you know, so that's.
You got to do the absolute value, absolutely.
Alright, we can.
Please stop.
Alright, there's precision. Okay, let's actually do a problem where we got to identify with numbers whether you are accurate, precise, both, or neither. In fact, why don't you guys try to do this one on your own here to see if you can do it. And please don't yell out loud if you think you know.
Nice job, Trinity.
Well, I don't know. We might not
Not
be right.
naming any names.
Yep, I'm
but-
wrong.
I realize
When the grand scheme.
What did I get upset?
All right. Cage, what do you think?
Well, it depends how you look at it, but
It's a little subjective, but I will argue one way or
I'm
the other.
gonna say it is precise only.
Yep.
That's it. So it's not.
Oh.
Here's why. Look at the unit you're measuring. Like if you were measuring this in centimeters and you were off like 0.7, or 0.6 centimeters, that's not much.
How big are meters? Oh, okay.
So you're off a half a meter, which is like this much. If you're measuring a car and you're off this much, I don't think you're very accurate, are you?
No.
How the heck?
What's Jeff's?
Jeff?
Yeah.
Okay? Does that make sense? So you gotta look at the unit you're measuring with and the context of the problem. That'll help. Does that make sense? For those of you who put both?
I didn't see
I don't know how big these units are, though, so.
Okay. Well, that's a problem. A meter stick? You've never seen a meter stick?
No. Oh, yeah.
It's like a
Oh,
yardstick
yeah, okay.
almost.
Okay, so definitely precise because listen, quickly, definitely precise because all these numbers are what to each other?
They're close.
Very, very, very close to each other. So then if you're comparing it, and you could do a percent error if you wanted to. You could have taken an average of these and do a percent error, and I bet you it's a good amount off. Okay? All right, the next one.
What's the first one?
I
This should be worker measurements, not was.
This is still hard to.
This one's hard.
How big is a volume?
How big is a gallon? You don't know what a gallon is.
How big is
A gallon,
volume?
okay.
Oh, okay.
Okay, you got
Not
one.
enough coffee.
You got one
That's
right
all
on.
it does.
Okay, this one's a little tricky. And your book would say one thing and I will disagree. That might have given away the answer.
Yeah. But we'll.
I'm gonna go out on a limb. Yeah, I don't know if I'm
Alright. And I'll debate with you guys. You can argue with what I think. On a test, it probably won't be this close. Who wants to give a thought? Gage?
I'd say it's between neither or accurate and.
Yeah, it's between those. The book would say probably what?
Average. I mean,
I'd say accurate.
It's
The
accurate.
book would say accurate. I would say neither.
Because the average is 12 and a 12.
Yeah, if you took the average, it's like 12 point what?
12 and a fourth. So
Yeah, 12.2.
that's still average
You're
of
all within
position,
2 gallons, is it?
not average of.
Gallon? I mean, a whole gallon off?
But it's the whole bathtub. Like,
So-
Wait, no, Mr. Kramer. This is still average of position. Because you could have 1 and 20 and the average be around 10. Or you could do 9, the average off is 9.
Okay.
I see what you're saying.
So that's still.
And I won't make it this close, but the reason why, first off, the reason why I'm not saying precise is we're off by as much as 0.9, almost a whole gallon between my measurements.
That's what I was thinking.
That's off quite a bit, I think.
But where do you know when to cut it off? Like, oh, that's too big of a.
Context.
Context.
Subjective context.
Yeah, I know, alright? Biblical context is equally as challenging, right? So, it's not easy. Context is never easy.
No, sir. They never said it was going to be easy.
Alright, guys. Have a blessed day.